Quantum computing sounds like it's straight out of science fiction, but under the hood, it's all maths. And the UK government has just committed up to £2 billion to bring a 40-year-old prediction into science fact. In a normal computer, information is processed with bits, which can either be 0 or 1, kind of like an on or off switch. In contrast, quantum computers use qubits, which are also 0 or 1 when you measure them, but before you look, they exist in a linear combination of both states, some amount of each. That amount is a weighting of how likely you are to find each value when you look. Since it's either one value or the other when you measure, the weightings always add up to 1. So if we were to plot out all of the possible states, we can see that there are infinitely many of them, all lying on a unit sphere. This linear combination of possible states is what people are talking about when they say superposition, with maybe just a little more hidden behind the curtain. Because of this superposition and entanglement, perhaps that's a topic for another video, a quantum computer can explore an exponentially large space of all possibilities all at once. 1 qubit gives you a combination of 2 possible states, 2 qubits gives 4, 10 qubits over 1,000, growing like 2 to the n. A classical computer would have to check each state one at a time, taking exponentially longer as the system grows. Real-world problems at the molecular level, like understanding how electrons behave in complex molecules, are exactly the kind of systems with these exponentially large space states. And as Feynman put it, if you want to simulate nature, you need a quantum computer, matching the tool to the problem at hand. For the last 10 years, the UK government has been investing in quantum research to become a world leader, and this new announcement is promising the shift from lab to reality. They're focusing on building and deploying quantum computers at scale to handle large real-world problems much faster, like designing more efficient batteries or development of new drugs. Today, drug development can take over 10 years and cost billions, and quantum can speed this up and reduce the cost. If you want to know more about the maths behind quantum computing, let me know in the comments.